Hi everyone, my name is Duncan Shepard and I'm with the Artificial Intelligence Club at UCI. I wanted to give a brief top-down overview of machine learning for beginners on the outside looking in, wondering if machine learning, and to a certain extent artificial intelligence as a whole, is a programming discipline they would be interested in. I'll talk about what machine learning is, what artificial intelligence is, and how machine learning relates to artificial intelligence. Then, I'll run over some of the types of problems that machine learning can solve. Next, I'll give an abstract explanation as to how machine learning solves these problems, and finally, I'll give you a few resources you can use to create beginner-friendly practice projects to get you started. Now that you know what's going to be covered, let's get straight into it. What is machine learning? You've probably heard about it, and maybe you even have a good idea as to what it's supposed to do. But it never hurts to know the precise definition. Machine learning is the study and application of how various computer algorithms can learn to solve problems by processing data. In this discipline, mathematical models are the main driving force of success, and much of the methodology originates from statistics. Note that machine learning is a subset of artificial intelligence. They're not one and the same. Artificial intelligence is a broad umbrella term that can be interpreted in a few different ways. For our case, we can define it by breaking down its two constituent words: artificial, meaning man-made, and intelligence, which we will be constraining to mean an agent capable of informed problem solving. Given our interpretation of artificial intelligence, we can see how machine learning fits under this idea, since machine learning seeks to create an agent capable of informed problem solving by building a mathematical model from various forms of input data. However, there's a reason why people can confuse machine learning and artificial intelligence as the same thing. Machine learning techniques, such as deep neural networks and reinforcement learning, have provided the most high-profile applications of artificial intelligence in recent memory. These applications rapidly push state-of-the-art technology and are so crazy that they dominate the topic in the present day. Speaking of applications, now that we know what machine learning is, what kinds of problems can it solve? Generally, machine learning is unreasonably effective at solving problems that involve large amounts of data. For example, creating a spam filter for email is a problem that cannot be easily solved by manually programming deterministic rules. However, there are a lot of spam emails out there. We can use that mountain of data to create a mathematical model that predicts whether or not new emails coming into an inbox are spam. Big data doesn't have to be readily available to solve problems with machine learning. It can also be generated by the computer algorithm itself. DeepMind's AlphaZero project is one such case, being an artificially manifested board game juggernaut that learned to play chess and Go at superhuman levels by playing games with itself. Other applications include visually recognizing and categorizing objects in images, dynamically animating 3D rigs, and even creating augmented reality effects with real-time depth approximation. There's a way to get a basic grasp of machine learning by exploring its three fundamental techniques: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning and unsupervised learning differ in the type of data that the machine learning algorithm is expected to learn from. On one hand, supervised learning involves data that has been labeled. That is to say, the supposed answer that our algorithm is meant to predict is already attached to items in the dataset. For example, going back to our email spam filter from before, if our computer algorithm is expected to process emails that have already been labeled as spam or not spam, then we would be using supervised learning. On the other hand, unsupervised learning is expected to process data that has no labels. An example of this involves a dataset made up of large passages of fictional text. If a computer algorithm is expected to find word relationships by clustering them together by meaning, then we would be using unsupervised learning, because this dataset isn't labeled. The last technique is the most different of the three. If supervised learning is like learning in a classroom, and if unsupervised learning is like learning alone through primary sources, then reinforcement learning is like learning a new physical technique through trial and error, with a coach letting you know if you did it correctly or not. This technique is an incremental process, where a software agent is taught to take certain actions by being rewarded for correct actions and punished for wrong ones. We made a cool example of reinforcement learning using Flappy Bird, where a software agent was trained to maximize score and fly for as long as possible. Now that we covered the three fundamental paradigms of machine learning, there are useful generalizations that can be made about machine learning by thinking of these three techniques in terms of a pipeline. For supervised and unsupervised learning, data passes through multiple stages of processing, much like water flowing through multiple stages of filtration. The first stage cleans up the data so that the computer algorithm can process it. Removing empty values or purging invalid data points is an example of this. The second stage trains the learning model on the input data. That is to say, a mathematical model is constructed that can correctly predict the desired features from new input data that the model hasn't seen before. This second stage happens in a loop, and each iteration of this loop, where the dataset is fully presented to the learning model, is known as an epoch. At every epoch, small adjustments are made to the model, and each adjustment makes the model slightly better at predicting the correct values. The first and second stages happen in tandem for reinforcement learning, since reinforcement learning often generates its own data and corrections while training. Lastly, the third stage gives new input data that the newly constructed mathematical model hasn't seen before. The model will give a prediction based on this new input, and hopefully this prediction is accurate enough to be useful. This way of thinking about machine learning definitely glosses over many of the underlying nuances between different machine learning techniques, and real machine learning pipelines usually have more than just 3 stages. However, knowing that you'll find something resembling each of these mentioned stages in most machine learning programs is a good initial reference point, since it will give you a basic framework to use when you start making your own projects. To get started with machine learning, I first recommend getting well acquainted with Python. Python is one of the best supported languages for machine learning, as it has many useful, easy-to-use tools to make data-driven programming easier. These tools include NumPy, a library that adds support for large multi-dimensional arrays and many important mathematical extractions to use with set arrays, Pandas, a library that adds data structures to represent tables and time series, and lastly, a few machine learning libraries to choose from. I would suggest starting with scikit-learn, and once you have a few projects done, you can move on to PyTorch or Google's TensorFlow. Check the description below for links to some great beginner-friendly machine learning projects that make use of these tools. Machine learning is definitely an overwhelming field to get into, but hopefully, after finishing your first few projects, you have a better sense as to what you would like to explore next. Thanks for watching. All of the references that this video makes, including video sources, are linked in the description. In the upcoming school quarter, we will be making videos and leading workshops that go into much more detail about all the concepts mentioned here. We'll go over some of our favorite projects that cover a variety of machine learning topics, and we'll also make quick tutorials on how to do some of the less glamorous parts of the process, such as setting up a virtual environment and using interactive Python notebooks. That's all for now, and I'll see you next time.